Okay, hi there. I've been really looking forward to this. We've been working on a Cerebral router. And the thing here is that we have not just been building a router for Cerebral. We've really been thinking about how does routing work and how can we do it better. And I just want to give a big thanks to Brian and Garth for being so enthusiastic about Cerebral, and we have been talking a lot about routing and doing tests and really done a lot of work to get to this point. And now the Cerebral router is just that is not where like the all the work has been done. The work has been done in two different projects. One project is called Address Bar, and the other project is called URL Mapper. So I will come back to that, but first I just want to talk about how does the router fit in with the architecture. So with Cerebral you have a view layer, it being Angular or React, and then you have Cerebral, which is like the entity that represents your controller layer. And there you do AJAX requests, and you basically define the state changing flow of your application. And that depends on a model layer that can be different kinds, like immutable store or Baobab or TCOM. And that is where you store the state is being stored. And this is how it works. So if we were going to use a traditional approach with the router, we would do something like this. We would create an entity on this, like next to the architecture, and the router would kind of like swallow the view layer. So when a URL changed, it would actually dive into the view layer directly and do changes to it, because that's what routers generally do. They do changes to what views should be displayed in the UI. But things get more complex because sometimes you want to load some data from the server before it's able to do these changes in the layout. And then the router goes to the server and it gets some data, and then it does the changes in the layout, but you still want to store that data in your state store. So the router also has to pass that data into like the controller layer so it can be stored in your state store. Now the problem here is that the router now does a lot of stuff that the original architecture is handling. Like the AJAX requests and the state changing flow is something that is already defined with Cerebral as signals. So it just doesn't make sense to like put this router in here, and it just ruins the whole architecture and all its benefits. So the idea here was that what if we split up routing from URLs? So I was thinking about this concept where what if the address bar was just an input? Because it's really hard to handle URL changes, and all the routing libraries today handles this stuff, but they also have a very opinionated way of what to do when the URL changes. So I wanted to split that out. So there's one library called address bar, and basically it just makes the address bar like an input. You can listen to changes on it and you can change the value of it without that triggering new like native route changes. So it makes it really easy to just listen to URL changes and act upon it. The second part of the Cerebral router is a project called URL Mapper. And what that project basically does is take a string and maps it to different functions based on URL definitions. So these two projects can be used to whatever other stuff, but now they have been combined into the Cerebral router. And what this allows us to do is handle URL changes like any other like input or interactions with your application. So it works the exact same way as everything else, and that gives us some pretty cool opportunities. So let's dive into some code here. I have a project here, and I prepared some code. So what we're going to do, let's see, let's start from the beginning here. Let me just show you the project first. We have a home page. We have if I click that, we see that there's a signal is triggered, which sets the title and the page. And if I hit messages, we have a different signal that sets the title and the page. And it checks whether or not we have loaded the messages. And if we have not done that, it will run a few actions just getting the messages. And then we also have the last signal here is message opened. And the thing is that now we have defined how our application should work without thinking about URLs. And that's kind of interesting, because very often you start out with thinking about the URLs and then you kind of like fit in the state changing flow of your application with those URLs. But what we're going to do now is go into the code here, and I have prepared a router. So what we're going to do is actually just fire up this router, and we pass it a controller. And that is because it needs to store some URL state inside using the controller, and it also needs access to the signals. Because what we're going to do now is define URLs as you normally would with a router, but we're going to point to the signals it's going to trigger on the different URLs. Okay, so if we are at the home page, we're going to run the home opened. We're going to use messages for messages opened, and we are going to use messages and ID for the message open signal. Okay, so when I save this now and the page reloads, when I now hit home, we of course don't see any changes to the URL because we are at home. But we can see that there's an action has been like injected into our signal, and that's called set URL. So it just sets the URL, or just sets the URL inside the state store. But what happens now is that when I click messages, we see that we have triggered the signal, but the route has also updated. So it's kind of like going the other way around. We are just triggering signals. We are not talking to a router or anything. We are just still triggering our normal signals because that is our state changing flow. But an effect of doing that state change is updating the URL. And that is really, really interesting. So even if I go to this dynamic URL now, we can see that it updates correctly and it runs the signal as it's supposed to do. And what's even more awesome about this is that I can still do time travel debugging, and we can see that the URL updates. So this is really, really cool. Now, what we're also going to do now is change this to use hashes instead, only hash true. Okay, so when I change that now, and again, we're still just triggering signals. If I go to messages, we see that we have a hash and some other message, just like that. Just to make sure that you trust me here, if I go to the app component and to these two links, home and messages, as we can see, it just triggers the signals directly, but the URL is actually being updated. Okay. So what we're going to do now is, if I go home, I can go directly to messages and 0. What we see now is that it did run the signal, but we can't see anything updating in the UI. And that's because that when we created these signals, it wasn't possible to trigger the message open signal without going into messages first. But since we now have exposed URLs to our application, that is actually possible. So what we have to do now is to make sure that whenever this message open signal runs, we also have to run the actions from messages open, just like that. Okay, so now when the message open signal runs, it will also run the actions from messages opened. So if I save that now, and again we go to messages 0, like that, and now it also runs all these other actions from our other signal. And what's really nice now is that we do not, like in a signal, tell it to run another signal first and stuff like that. We're just reusing the actions. So what's so great about that is now you see this action chain being longer, and you can see all the actions being triggered to actually produce this interface. And it just gives you a really, really nice overview. So again, this is actually what I wanted to show you. And what to take notice of here is that you can develop your application and create all your signals, and then you can hook on the router actually later, because you hook URLs to signals. If you are a bit confused about the spread operator here, it is just basically taking an array from these files here, these signal files, and just spreads the items of those arrays as arguments to this signal definition. So let's just take a look at, for example, home opened. It's just an array, and it has 2 actions, and those are being spread onto this signal. Okay, but this is what I wanted to show you. I hope this was an okay introduction to routing with Cerebral, and I hope you see, like, can I call it innovations, or how we can think differently about URLs. They are just a product of your state changes. They are not what defines how your application should work. Okay, thanks for watching.